All right, part 1 of 13.3, we're going to talk about what a sequence is. All right, we're going to talk about 2 different kinds of sequences, very specific. We're going to talk about arithmetic or arithmetic, however you want to say it. That's 13.2. And then geometric is 13.3. There's very specific differences between the 2. But today we're just going to talk about sequences in general. All right, a sequence basically is just a list of numbers. 13.1, yeah. It's just a list of numbers. So if we look at this list of numbers right here, you guys see the list I'm talking about, 5, 10, 15, 20. Could you figure out what the next few numbers are going to be? Yes, what would you tell me the next few are going to be? 30, 35, 40, 45. Why do you just assume that those are going to be the next numbers? Because each one of the preceding, it goes up by 5. All right, so we're going to, in the next 2 sections, we're going to figure out what's called the rule. This would be the rule right here. We're going to figure out what a rule is so you can find the 50th term of a sequence, the 17,000th term of a sequence. So you don't just, if I said to you, what's the 20th term? Right now, you guys would just keep adding 5 20 times, right? But that doesn't become very effective when I ask you to find the 358th term. So you'd have to add 5 358 times. That doesn't make sense. So we're going to figure out how to write the rule. This would be the rule down here. Okay? Now, if you notice here, this says like A sub 1, A sub 2. Do you see what I'm talking about here? A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Those are the term numbers themselves. Like if I said to you guys, what is the first term of this sequence? You would tell me it's what number? 5. What's the 4th term? 20. Do you guys understand so what's the 5th term? 25. So that little, like when I say A sub 1, A sub 5, A sub 12, that little number is the term number that you're talking about. So in this case, when we're talking about sequences and first term and second term and all that stuff, N is the term number. So the first term is A sub 1. The second term is A sub 2. When they ask you what the nth term is, that just means it could be any term. I could ask you what A sub 9 is. That means what's the 9th term? If I said A sub 42, what's the 42nd term? So you're going to have a rule. You're going to have some sort of an equation that has an N in it. And when you're looking, whatever number term you're looking for, that's what you plug in for N. All right, and I'm going to show you the difference of different kinds of rules and specific ones that we're going to end up writing, but not today. We're just kind of looking at the rules themselves, like just finding stuff. Now, these first 4 questions are exactly as easy as they appear. But here's the catch, all right? This is the first 8 of your WebAssign are just like these. You have to show me what you put in your calculator or in your brain. If you just tell me answers, I am not giving you credit on WebAssign or on your quiz. So what this question is asking, find the first 5 terms and the 100th term. Well, N is your term number. So if I want to find the first 5 terms, what numbers am I plugging in for N? 1, 2, 3, 4, and 5. If I want to find the 100th term, what number do I plug in for N? 100. So everybody do this with me. Letter A, this is what your homework should look like, and this is what your quiz should look like. You're going to say to me, okay, I'm going to find the first 5 terms. So A sub N equals 2N minus 1. So I'm going to find the first term, the second term, the third term, the 4th term, the 5th term, and the 100th term. This is what I have to see. If you do not give me this work, I am not giving you credit. Very simply, guys, you plug in for N. So I have 2 times 1 minus 1 equals what? 1. So I have 2 times 2 minus 1. Well, 2 times 2 is 4. 4 minus 1 is 3. So then I'm going to plug in 3 for N. So 2 times 3 minus 1. What's 2 times 3? 6. 6 minus 1 is 5. So then I'm going to find the 4th term. So 2 times 4 is 8. Minus 1 is 7. Good. Fifth term, I'm going to plug in 5. So 2 times 5 minus 1 is 10 minus 1 is 9. And then 100. 2 times 100 minus 1. Well, 200 minus 1 is 199. So the first 5 terms of this sequence are 1, 3, 5, 7, and 9. Correct? When I put ... what does that mean? Keeps going. It continues. So what you're doing today, all we're doing is figuring out specific terms. If I said to you, what is the 527th term? What number would you plug in for n? 527. What we're going to do starting Wednesday is we're going to take this sequence of numbers and we're going to figure out how you get from one number to the next, and then we're going to write a rule for that. So we're going to go backwards. Today we're just evaluating. We're just finding different term values. Does that make sense? So for number 2, or letter B, okay? Each one is a little different here. Letter B. I have, you can always use A if you want to. A sub n equals n squared minus 1. So again, we're going to find the first 5 terms. And the 100th. So I have n squared minus 1. So I have 1 squared minus 1. Well, 1 squared is 1, and 1 minus 1 is 0. All right, so then I'm going to plug in 2. So 2 squared minus 1. What's 2 squared? 4, and 4 minus 1 is 3. So now 3. So I have 3 squared minus 1. What's 3 squared? 9, and 9 minus 1 is 8. Good. So 4 squared minus 1. What's 4 squared? 16 minus 1 is 15. 5 squared minus 1. 25 minus 1 is 24. Okay. 100 squared minus 1. 100 squared is 10,000. Minus 1 is 9,999. So the first 5 terms of this sequence are 0, 3, 8, 15, 24. And it keeps going. Now, what do you notice in the red one? How did we get from 1 to 3? Add 2. Okay. How did we get from 3 to 5? Add 2. How'd you get from 5 to 7? Add 2. How'd you get from 7 to 9? Add 2. Are you adding the same thing every time? All right. You'll see this on Wednesday, but that's called an arithmetic or an arithmetic sequence. When you add or subtract the same thing every time. This rule is 2n, a sub n, equals 2n minus 1. This is called a linear function. I could rewrite this as 2x minus 1. Y equals 2x minus 1. What's your slope? 2. When you have a linear function or an arithmetic sequence, it's the slope. You're going to add or subtract the same thing every time. Now, if you look at this one, is there a pattern? How'd you get from 0 to 3? Plus 3. How'd you get from 3 to 8? Plus 5. How'd you get from 8 to 15? Plus 7. How'd you get from 15 to 24? Plus 9. There's a pattern, right? That's where this rule came from, n squared minus 1. But this is not an arithmetic or an arithmetic. You're not adding the same thing every time. This also is not a geometric. You're not multiplying the same thing every time. Those are the 2 that we're going to focus on to write rules. You guys aren't going to have to write rules that aren't arithmetic or geometric, but I just want you to understand the differences between. All right, so let's look at C. Yep. A sub n, again, you can use whatever letter, is n over n plus 1, right? I know this might seem super basic, guys, but again, as some of the rules get a little more involved, you've got to pay attention. If you're going to find the first 5 terms, a sub 4, a sub 5, and then the 100th, notice you're plugging in for where? Plugging in for n, right? But where is the n? Is there just one of them? There's 2. So you just got to pay attention to what you're doing. Just be careful. So I'm going to say the first term is 1 over 1 plus 1, which equals what? Okay, so 1/2 is our first term, right? So now I'm going to plug in 2 for my n. So I have 2 over 2 plus 1, which equals what? Okay, so 2/3. Then I'm going to plug in 3. So I have 3 over 3 plus 1, which equals 3/4. 4 over 4 plus 1, which equals 4/5. 5 over 5 plus 1, which equals 5/6. Everybody with me? So I'm going to have 100 over 100 plus 1, and I have 100 over 101. So the first 5 terms of your sequence here are right there. Are you adding or subtracting the same thing every time? No. Are you multiplying the same thing every time? No. So this is neither geometric nor arithmetic. And again, we'll talk more about that on Wednesday. All right, our last one. And again, I'm bringing up different things just so you guys are aware. You're allowed to use calculators 100%. Again, I'm just going to use A. I know it's an R. I'm just going to use A. So -1 to the n over 2 to the n. Now, you guys have to be really careful. If you were to punch it in your calculator, -1 squared. Okay, tell me right now, everybody, what is -1 squared? 1. If you right now in your calculator, exactly how I wrote it, put -1 squared, your calculator would tell you this was -1. And some of you would tell me that your calculator is broken. And I'm going to say, no, you're broken. Your calculator is only as smart as the user. What do you have to put? Parentheses. Remember, negative numbers are sad. They need a hug. Okay? Before you put them in the calculator, when you put a negative number in the calculator, you've got to put it in parentheses. Because you have to tell the calculator, hey, square the number -1. If you don't, your calculator will square 1 and then multiply it by a negative. So just be careful. This is a very simple problem, but you don't want to make a mistake because you didn't input it correctly into your brain or your calculator. So again, we're going to show all of our work here. We're going to find the first 5 terms and then the 100th term. So I'm going to say -1 to the first power over 2 to the first power. All right, so what is -1 to the first power? -1 over 2, so it's -1/2. So now if you're going to find to the second power, you have -1 squared over what? 2 squared. What is -1 times -1? -1 times -1. +1 over 2 squared is 4. So now we're going to plug in 3. You have -1 to the third power over 2 to the third power. What is a negative number raised to an odd power always going to be? Negative or positive? Negative. So this is going to be -1 over what? 8. So now I come down here. I have -1 to the 4th power over 2 to the 4th power. What's -1 to the 4th power? 1 over, good. 16, good, Bamford. So then I have -1 to the 5th over 2 to the 5th. What's -1 to the 5th power? -1, good. What's 2 to the 5th power? 32. Now this last one ends up being a ginormous number. So -1 to the 100th over 2 to the 100th. You're going to get some sort of scientific notation. So the way that you need to enter it into WebAssign, I'll show you. But what is -1 to the 100th power? Think about it. Is 100 even or odd? It's even. So it's 1 over, and then you get something in scientific notation. So just leave it at like this. I think on WebAssign, you guys have one that's like 3 to the n or 4 to the n, something like that. And they ask you for the 100th term. So just enter it like this because you'll get scientific notation. So you just leave it. No, not for WebAssign. I'm not going to give you one on the quiz that big that you get scientific notation. So do you guys understand? For the first 5 of your WebAssign, all you're doing is determining the first however many terms that they ask you for. But I need to see this. I know you guys you think it's redundant, you think it's silly. I understand that, but you've got to plug this into your calculator, get familiar with your calculator, show me the work that you're putting in. Sound good? All right, what we're going to do tomorrow, we'll talk about 1 second. We're going to talk about sigma notation, which sigma is just a Greek letter. Once, if you guys look at it, you're going to be like, what are you talking about? And then as soon as I explain it for 30 seconds tomorrow, you're going to be like, oh, it's really easy. Just another way to say stuff. But we're going to talk about partial sums and adding stuff up and all that good stuff. But if you want to find a rule for the nth term, that's what we're going to be doing with arithmetic and geometric, 13.2 and 13.3. We're going to write the algebraic rule. Then you're going to find the rule. The ones that we're going to write, it's either that you're going to add the same thing every time or you're going to multiply the same thing every time. So think about this. Look at this first one. I know you guys see a pattern. Look at the numerator. What's happening every time in the numerator? How'd you get from 1 to 3 to 5 to 7? Adding 2. Okay, what'd you do on the bottom? Add 2. Right? But then the top is odd, the bottom is even. So if I asked you for the next few terms, could you tell me what they are? Yes, you guys would tell me that the next term is what? If I added 2 to 7, it's 9 over. If I added 2 to 8, it's 10, right? Then it would be 11 over 12. Then it would be 13 over 14. You guys agree? Okay. But could you write the algebraic rule for this? You actually could, but we're not going to. We're only going to write rules if you're adding something, adding or subtracting, the same every time, or multiplying. So this one would not be arithmetic or geometric. We would not write a rule for it. But for the next one, how'd you get from -2 to 4? Okay, you could square it. Good. But we're trying to figure out how we could do the same thing every time. Then how would you get from 4 to -8? From the -8 to 16. We're going to multiply each time by a -2. Notice how the signs flip. You guys see that? That's an indication that it's geometric. If you're multiplying by a negative, your signs will flip. It'll go from even to odd, positive, negative, that sort of a thing. So this would be a geometric, which is in section 13.3. Like I said, we'll talk about that later. All right, you guys good? Okay.